We are a team comprised of urban planners, landscape architects, and computer scientists, combining various elements of our individual studies to be a catalyst for a smart and sustainable economic development in Nolanville, Texas. Our objective is to create a more sustainable economy that would help improve the overall quality of life in Nolanville and further contribute to its tight-knit community. With our wide range of skill sets, we have had the tools to plan our project's character and identity, create visual conceptualizations, and even collect and analyze community data. Everyone on our team has brought their own expertise to the table, ultimately helping continue the process of bringing our vision to life.
We will be providing a small fabricated container space to be used by KOM Cyclery to fully operate their bike shop out of. Our goal is to successfully equip KOM Cyclery with a comfortable and sustainable workspace that allows the company to fit in with the community and ultimately become a key piece in the area. Getting the bike shop set up is our first step in exemplifying how a small container space can successfully integrate a new business into the community. Upon completion of the bike shop, Team Catalyst hopes to continue assisting the city in the future by setting up more sustainable workspaces that similar companies can work out of and find success with. Throughout this semester, we have successfully made progress planning our development's character, renovating our container, creating conceptual plans, and producing various data to be analyzed to further accommodate the city's economic and societal needs.
Displayed below are a few different images of our actual container in different stages of its development. Going from left to right, we see where the container was originally delivered to Texas A&M campus earlier this semester. We then handed it off to Build Services, where the container went under construction and made the necessary changes for our project's vision. Third step was the container being transported to Nolanville, and the last step, which happened in this most recent week, the container was successfully delivered to Nolanville. Going into this project, the goal for the planners was to find a way to incorporate a unique and distinguishable character into our project that would create a friendly and reliable identity within the Nolanville community. We aimed at doing this by gathering a few different case studies to take inspiration from and also incorporate their central themes in our own way. The first one was Parque de las Palapas, which encompassed the idea of a centrally located hub serving as an entertainment district and a feeling of home away from home within its own community. Secondly, we used Hangers Cleaners, which showcased the power of small business by adapting to local culture and establishing personality within the community, making them feel like they have a sense of belonging and bringing them tighter with its own community members. The third and final one was the Flophouse Hotel, which was truly a sustainable development that operated out of containers similar to our project and also used recycled materials that gave it an environmental advantage and also an aesthetic appeal, something that we are also aiming for within our own project.
The master plan for this site creates a plan for the city to reference and utilize moving forward while developing their economic district with the standards now set through the Catalyst project. The design allows for future container layouts on adjacent properties to allow for cohesive design, as well as implementing a pedestrian-focused street, allowing people to safely and freely move throughout the space. The plan also utilizes the southern property currently owned by BNSF Railways, with the hope of creating an open play space as well as implementing a walking trail and play area or park for families and children to experience.
We've created 3 different site orientations. Option 1. The containers frame the edge of this space with a large central green, helping to create a sense of place. In the rear is a bermed pump part. Option 2. The containers are oriented to the left-hand side of the site, leaving room on the right for future development. Located in the rear is a symmetrical bermed pump part. Option 3. The containers are also oriented to the left-hand side of this site, leaving room for development on the right. This option includes a drive-through for the coffee shop. Also located in the rear of the site is a larger bermed pump part. Option 1 Perspectives. Option 2 Perspectives. Option 3 Perspectives.
part of our team's objective was constructing a model that could prove or disprove solar feasibility, which is to say whether or not it would be advantageous or even possible to implement solar panels in order to collect solar energy production and convert it into usable energy for the container. This was done by training a regression model that used data from a previous study done that allowed us to predict the power generated by solar panels on a given day, taking into account weather and seasonal conditions and changes. The model takes as inputs humidity, ambient temperature, wind speed, pressure, and visibility, and gives as output the expected power generation on an up to hourly basis, which allows us to not only understand whether or not the solar energy model plan is feasible, but at what times it would be most effective, and whether or not we would want to fall back to an alternative plan during those times in which it's not as effective.
Using a data set from a previous study on forecasting solar energy, we trained two different models, a linear regression model as well as a random forest regression model. After that, we collected weather test data from Fort Hood, a military base around 7 miles west of Nolanville, since there was no weather station data for Nolanville itself. From these tests, we found that the power output is generally greater during the summer months, which is due to higher ambient temperatures as well as increased visibility during the day. The results of the test can be seen in the graphs on the right, and you can also view the accuracy of each model. After we completed testing our model, we extrapolated the outputted energy data to the average cost of energy per kilowatt hour to look at how much money could be saved. According to Reliant Energy, the average residential energy usage is 1,176 kilowatt hours per month, which costs 11.56 cents per kilowatt, which is about $136 per month or $1,632 per year. When taking the cost of electricity into account, we estimate that solar energy can save between $1,900 to $2,400 US per year when using a 10 kilowatt solar panel system.
A presentation including the base quotes on our preferred solar panel installation feature, as well as the benefits of solar energy, has been created and presented to our first client. As you can see to the right, the economic benefits include tax credits and bonus depreciation information, as well as other general solar energy information. Using this, we will create a sidebar detailing the overall benefits the development and the clients may receive from this installation. In another topic, we have taken into consideration implementing plants directly into our design, such as including a vegetated roof onto our shipping containers. After a conversation with Life Roof Texas, more logistics will have to be researched as the containers cannot typically handle their structural requirements. To the right, you can see an example of a project that they have already worked on, Life Roof Texas, on a shipping container, which ultimately did not have the structural capacity to completely bear the vegetated roof. So another alternative could be to use the face of a container and implement a green wall, such as vines running down on it. This design, however, is high maintenance and would require regular care. Our mission is to ultimately create a framework in which other small towns looking to revitalize may adopt the same principles. Therefore, we have decided to create two forms of attaining a community profile and creating an accessible format for these towns. One of them is a community survey. Using Google Forms, we have created a survey with 10 questions regarding personal respondent information and thoughts on the project. As you can see on the right, this is a survey that is currently in use. On the other hand, we are also planning on implementing a comprehensive plan. By the end of the project, we are to create a comprehensive plan that includes the main vision of the project, the survey results, the conceptual plans, the solar energy information, and specifications utilized for the shipping containers.
Looking into the future, we have various aspects of design, sustainability, and planning ahead of us that we are all very excited for. On our design side, we have found an artist that is interested in adding exterior wall art to our container next. Sustainability speaking, we are continuing to explore our solar panel options and may even be installing on a shading structure in the near future. As far as our planning goes, we are currently working on a comprehensive plan that will detail the projection for the container site in the years to come, as well as future businesses or amenities that could be integrated into the subject area.